Shift registers are very useful devices for input or output expansion given the limited number of available IOs. Here, the MCU or the processor, which usually are constrained on the number of available GPIOs, usually limited to 2 or 3, can control 8 or multiples of 8 outputs through the output expansion capability of the HC595 device. Similarly, the output of the shift register combined with high drive buffers could be used to control stepper motors. The output expansion using shift register is used here to control the 7-segment LED display. Popular devices include AHC595, HC164, CD4021B, HC595, etc. HC165 device can be used as parallel load serial out shift registers, which aids in input expansion. This is the reverse of the output expansion we just looked at using the HC595 device. Let us now go a little deeper into understanding the output expansion using shift register of the popular HC595. The SER pin is the serial data input into the shift register. The SR clock is the shift register clock input, which clocks the serial input data into the D flip-flop. The output of the flip-flop connects back into the next flip-flop as well as the first output register. SR clock is positive edge triggered, and after 8 clocks, the data propagates into each of the 8 flip-flops. The R clock is the register clock and is positive edge triggered as well. When R clock is clocked from low to high, the data is output simultaneously from QA to QH pins. The R clock is specific to HC595, but some devices like HC164, HC165 doesn't have R clock. The other control inputs, namely the output enable, the SR clear, may or may not be used in the application. The HC595 device also has a QH prime output, which can be connected to the serial input of the next shift register to achieve multiple of 8 outputs. This is called daisy chaining the outputs. TI designs and booster pack representing the use case for the shift register is shown here. It uses the HC595 combined with the ULN 2003 low-side driver to drive stepper motors. This TI design is used in building automation for HVAC louver control. It can also be daisy chained with 2 other shift registers to generate 24 total outputs using just 3 GPIO inputs to control 7-segment displays, drive LEDs or buzzers, etc. Here is another TI reference design which uses the HC595B shift register and also combines the LVC244A driver buffer. It highlights the output expansion capability of the shift register to drive 7-segment display and an 8x8 LED matrix. Both the HC595B and the LVC244A are available in the industry's smallest logic QFN package, the X1QFN, and it fits conveniently behind the 7-segment display. It comes with an area size of 6.25 mm², which is about 3x lesser area as compared to 22 mm² size of the standard TSOP package. D flip-flops can be used for dividing a clock frequency by 2 by connecting the Q bar output back to the D input. A counter can be used for 2 to the power of n clock division using the similar concept. For example, a 4-bit counter can be used for 2 to the power of 4 or 16x clock division. SR flip-flop is used in synchronous buck or boost converter to control the on timing of the pass FET and the reverse current conduction FET based on the clock input and the comparator output voltage as shown here. Popular D flip-flop devices include LVC1G374, AUP1G74, LVC2G74. Popular counters include HC163 and HC193.